Hello everyone. So today, as promised, is gonna be WinISD tutorial. WinISD. There we go. So if you go to Google, put WinISD, and you have the first link, you can download it. You can install it. It's free. It's kind of old. It's 2016. There are a few different software that can do almost the same thing, but I like WinISD because I use it the most. Yeah. So when you download it, I'm gonna show you how to do that. You can do it yourself. You have this window, yeah, and it's totally blank. So first of all, what does the software actually do? It basically gives you a frequency response, a prediction of the bottom end of any driver depending on which enclosure you're going to use it for. Yeah, it uses formulas because using math you can figure out a lot of stuff. Okay, so what you need in order to have that graph, you need your driver, your subwoofer, whatever you use, TS parameters. How do you get them? So I have my driver is Alpine Type X. If I would go to the manufacturer's site and I'm gonna download a manual, I have it already here, and it's gonna give me all of these things. So I have TS parameters on this side. Okay, so X series, nope, remind me later, never, sorry about that. Okay, so X series 12 inches is the big one, and we have all the parameters here. So for some subwoofers you have more parameters, for some less. If your manufacturer doesn't give you any TS parameters, sorry to say, but it's a shitty manufacturer because all of them have to give you something. And for Alpine gives me as well on this side recommended box, recommended enclosure. So seal box range, vented box, so that's ported box, and it gives me all the data. So what we're gonna do is we're gonna enter these parameters just to show you how it works. Okay, WinISD. So when you're gonna open it, it's gonna be like this blank, so you have no idea where to start and what to do. You click on this blank page, create new project, and here you have different manufacturers, but again, it's from 2016. So if your sub is new, it's not gonna be here. We're gonna add a new. Okay, I'm gonna shift this to the side so I can see everything better. And here you have manufacturer, Alpine, brand, Alpine, model, that's X, 12 inch, and 4 ohm coils. So this is just the general. If you want to add something else, then we're going to go to parameters, this tab, parameters. Now, when we enter the parameters, TS parameters, they are intertwined into each other because you can derive one from another. So you not necessarily need all of them because some of them are going to be calculated automatically. So this at the bottom, auto calculate unknowns. Because for example, if you take QES, QMS, if you're going to add these two, the QTS is going to be derived from those two. So let's do that. QES, where is it? QES 062. Okay, QMS is 563. And now when I press enter, or I'm gonna do, you see this QTS? I'm gonna shift it here. See, it's calculated automatically. If you overwrite this, what is calculated automatically, and you're gonna save it, it's not gonna work. Whenever you're going to try to open this particular sub, is going to give you an error and it's not going to let you to calculate. So bear in mind, when you enter TS parameters, don't overwrite whatever is calculated automatically. So QTS, I'm not going to enter it, I'm going to leave it. Now FS, resonant frequency is 27 Hertz, 27, okay. MMS, do I have MMS? I don't have MMS, which is fine. Okay, CMS, I don't have it. What do I have? I have resistance, 3.6. That's gonna be 1.8 in series. BL, do I have BL? I don't. So see, that's not all of them. What do I have? Okay, let's go from the LE. Okay, LE is 4.42. 4.42. Okay. Do I have SD? Is the cone area 475. 475. And now you see it automatically calculated this. Now I do apologize for my American friends, because everything that I'm gonna be using is gonna be in meters, centimeters, liters, is gonna be like in European units, because I don't know any imperial units. I know roughly what is a foot, but I don't never use it, so it's gonna be everything in these units. Okay, what else do we have? X max is 24. Okay. What else? So see, automatically calculated VD. So VD is the displacement, which is SD times X max. It does calculate it automatically. Okay, what else do we have? VAS, 56. So is this one 56? And see, it populated even more stuff. And for example, if we take SPL, it calculated it at 84, and in the manual is 84.3, so almost spot on. Okay, is there anything else I can enter? This? Nope, that's it. XLEM, so this is mechanical limits. I'm gonna put 82. That's peak to peak, so it's gonna be 41 one way. And power handling, P, that's 900 watts RMS. Okay, and see, even from these, they're not all of them, but it auto-populated almost everything, so we have everything. Now we're not going to go into everything else because it doesn't really matter for us, and I'm going to save it. Alpine X. Cool. So now, since I saved it, I have it in my database, and now I can do some modulation predictions. So we're going to do first, the simplest one is a sealed enclosure, yeah? So I'm going to create new project, Alpine, this one, and X, this one. I'm going to click next. Now it's going to ask me how many drivers I want to use. I'm going to use only one driver. If you use two drivers, you can do isobaric if you want, but I'm going to use just one, normal. Next. Now it gives me an option to choose what kind of box I want to use. Do I want it closed, ported, fourth order bandpass, sixth order bandpass, passive radiator? So for first example, we're going to use a closed, so sealed box. Next. And this, I'm not going to go into too much details, but all you need to know is that this one is 0 point, it's a Q of the box. So 0707 is gonna give you like the flattest response with the most bass, or the shallowest roll off or something like that. Yeah. So we're aiming to extract the best that we can out of the subwoofer. Quality wise, for a sealed enclosure, we're aiming for 0.7. That's why you have like an infinite baffle. You want your subwoofer to be as close to 0.7 as you can, because there's no box. Okay, I'm gonna click next. Project name, let's name it X sealed. Next. And this is the graph that it gives me. So if I'm gonna go here here on the side, you have all your projects. We're going to open more. We're going to make some more projects. On the top where you see transfer function magnitude, you can click on it and it's going to give you different options. We're going to go through a few of them. This is the main graph. And on the side, you can change some stuff. So the driver, we're going to leave it the same. The box, we're going to click on the box. And as you can see, to have a QTC of 0.7, I need to have a 4 cubic feet box. And in liters is going to be 118 liters. So just for now, let's keep it in cubic feet. If you click on the unit, it's going to change it, yeah? So 4 cubic feet to have a QTC of 0.7, which is massive. Let's see what Alpine recommends in the manual. In the manual, if I'm going to go here, seal box range is from 0.4 up to 1.25 cubic feet. So me personally, when I had it in sealed, I made a box of 1.5. So let's put 1.5. And as you can see, this response changed, yeah, compared to that one. Now it has, so this is the 0 dB, and it has a bit of a hump here and a roll off. So this gives me a QTC of 0.86 and a box resonant frequency of 48 Hertz. So this is the sealed that I had in my car. Okay, if I'm gonna go to options, you can change these axes. You can, if I'm gonna click here and plot window, here you can change the frequency response. So frequency range, I would like to keep it between 20 and 150 because it's a subwoofer. If you're going to be doing a mid-bass or a mid-range, you obviously will need more because you can do it for a mid-range. For example, if you have a 2 or 3 inch mid-range and you want to put it in a closed sealed pod and you don't know what size pod to use, you can model it here as well. So 150, I'm going to leave it there. Cool. So this is sealed. Now, let's create a new project, X, and this time, one driver, we're gonna put it in vented box. Okay, so this, I don't know what these differences are. I'm not gonna, because the thing is we're gonna change the box dimensions, so it doesn't really matter which one you use. Next, now we're gonna put X ported and create. Okay, so what it gives me, let's put some reasonable dimensions. Let's put 3 cubic feet tuned to 30 Hertz. Okay, now for this project, let's make another one because I want to put the Alpine recommendations, okay, what it recommended in the manual, just to see. So let's put X ported recommended. So this was recommended. So Alpine recommends for recommended vented box. Okay, so we have net internal volume 1.65. So 1.65. And it doesn't give me a tuning frequency, but it gives me port dimensions and port length. So I do know because I did this before. So these port dimensions correspond to a tuning frequency of 30 Hertz because I did this before, so I know. So Alpine recommends this in their manual. The blue one is sealed and the green one is ported. Now, question is, what do I want from my subwoofer? I would like it, so I could, if I'm gonna unclick all of these, I could make it extremely large, let's say 6, oh, sorry, that was this one. I could make it, let's say 6 cubic feet tuned 20 Hertz. and that would give me a flat response down to, I don't know, let's check till when. Let's put 5. Yeah, so down to 18 hertz. Let's change this again because it's a bit, let's put 15. There we go. So this ported box would be amazing frequency range wise. However, it's highly unpractical. This volume, it's a chamber's volume, so this is net volume. It doesn't have any materials that you're going to use, and it doesn't have the port, because a port, big massive port tuned to 20 hertz is going to be another maybe cubic foot or a cubic foot and a half. So this box is unreasonable. It's not going to literally fit anywhere. Now, what can fit in my boot? I had a Kicker L7 12-inch that I made a box for it, which was 3.25 cubic feet tuned to 33 hertz. So I know that this box fits. Now I can make it a tiny bit larger. I can make it 3.5 just to extend it a bit more. And as you can see from this, if I'm gonna have a box of 3.5 cubic feet tuned to 33 hertz, I'm gonna have this response, which I quite like it. So my goal from this box that I want to make, of course I'm going to make it just for testing, but for listening purposes, I would like it to have a peak at about 35 hertz, 34, 33, because the music that I have the most, like hip hop and rap and that kind of stuff, it has main bass notes between 30 and 35 hertz. So if I would like to hit 30, obviously I need to tune it lower. So let's try 30. Yeah, that looks better. Yeah. So this is like, what do I have? +4, and here +4, and here 5.5. So basically I have this little peak from 30 hertz till 45, which is a peak, which is amazing. So this is what I would like to have, and this is my goal. Now, is this practical? I don't know, we will see. So this is only the frequency response. Now I need to know if my subwoofer will like to play this. Is it gonna be happy playing this? And the main thing that we're checking is the excursion. Yeah, we don't want the subwoofer to bottom out. We need for it to be in control. And we check this by going here on the top, and instead of transfer function magnitude, we're choosing cone excursion. And now it gives me 0 because I'm not giving it any power. If I'm gonna go here at the bottom to signal and system input power, I'm gonna give it full RMS, 900 watts. And this green graph is showing me the excursion depending on frequency. Yeah, so this is what I need to watch. If you remember from the manual, this subwoofer has X max of 24 mils. So 24 mils is here. And I'm reaching X max only below 22 hertz. So that means that I'm super happy playing it with no subsonic filter, because I'm not going to be playing any music that is lower than 20 hertz, let's say. Okay, so let's, for example, imagine I'm going to put more power. I'm going to put 2000 watts. Let's imagine that this particular subwoofer has an X max of 17 mil. Any other subwoofer, yeah? And this is how you check. You put the RMS value and you have your X max 17 mil. So that means that in this particular box, that you have 3 cubic feet tuned to 30 hertz, that subwoofer would bottom out below 27 hertz, and it's gonna have problems here. It wouldn't be linear. So Xmax is a bit weird measure because it doesn't mean that if you're gonna go over your Xmax, you're gonna damage the sub. That means it's not gonna be playing linear, so it's gonna add distortion. Yeah, so if you don't care about that, that's fine. But if from the SQ point of view, from sound quality point of view, you wouldn't want to go over your Xmax. So if I'm gonna have this box, I have two options. Either make the box smaller. Let's put 3 cubic foot, not that much. Let's put 2. See, this one is going down, but not as much. So that means that I would need to limit my power. So instead of 2K, I'm gonna put, let's say, 1.5K, almost 1.4. Perfect. So in this case, I would need to limit the power and have my subwoofer playing only 1400 watts instead of, if it's rated, let's say 2K, yeah, less. So that means if you're putting your subwoofer in a bigger box, you need to give it less power because it's gonna go over excursion. So let's go back to our particular example, 900 watts. And this subwoofer has Xmax of 24. So this means that in this particular box, if I don't play below 22 hertz, it's not gonna over excurge and it's not gonna get damaged and nothing is wrong gonna happen to it, which is perfect. Now I'm gonna go back to this. Now, for a sealed enclosure, you have only the volume, nothing else. For a ported, you have the volume of the enclosure and the port. If we're gonna go here to vents, we have number of vents, shape, diameter, that kind of stuff. So in this build, I'm gonna make not a circle, I'm gonna make a slot port because it's easier for me, yeah? And to check what size port I need, the area, I need to go here into rear port air velocity. So it's gonna give me, let's say, how should I put it? Chuffing. If it's gonna chuff or is it not gonna chuff? If I'm gonna hear it or not. The general consensus is, on the left side, you have air velocity in meters per second. The general consensus is that 17 meters per second is kind of a limit, that below that, you're not going to hear the port. Above that, you're going to hear the port. So in this particular case, if I'm going to leave it as it is, if I'm going to have my slot port at 10 times 10 centimeters and whatever length is supposed to be, and I'm going to play music. So everything below, above 42 hertz, like 50 hertz, 60 hertz, I'm not going to hear anything. I'm not going to hear the port. Everything is going to be nice. If I'm going to play music at 30 hertz, which I even cannot see it, where is air velocity? Let's put 50 so I could see it. You cannot see it even then. Let's put 70 meters per second. Okay, so at 30 hertz with this port, 10 times 10, which is very small port, it's like, okay, so how much is it inches? 4 inches, okay? So 4 times 4 inches, which is extremely ridiculous small port. If I'm gonna play 30 hertz, it's gonna be chuffing. You can hear it, you will definitely be hearing it, okay? So what I need to do, I need to lower this port velocity. And how I do this, I make the port bigger. So my box, I know the rough dimensions that they're gonna be. I know it's gonna be like 30 centimeters wide or tall. So in feet, it's gonna be like close to 1 foot. So I'm gonna put 30 centimeters here, and then it calculates the length that I need to hit my tuning frequency of 30 hertz. and I can manipulate the height of the port. So I have the width, and I can manipulate the height in order to have the velocity, air velocity, as I need it. So let me put this graph back, let's say 30 to make it a bit, there we go, you can see it. So it's 17, okay? So 17 is kind of the limit. And with this port, 30 times 10, it should be fine. At 30 hertz, I have only 20 meters per second, which might be audible, but not very much, but it's gonna be fine. However, if I'm gonna make the port like this, the port itself is gonna be big and it's gonna take a lot of space. So I need to kind of balance it out to make the port a tiny bit smaller so I can risk of hearing it, but I still need to fit the box in the car, you know? So if this port is gonna be, I don't know, a cubic foot, which I'm gonna add to the net volume of the box, so that's gonna be 4.5 cubic foot, plus all the material, another maybe foot or whatever, it might not fit. So I'm gonna try to make the port a tiny bit smaller, and I'm gonna risk it. So first of all, the signal, I'm not gonna be listening to full tilt all the time. And even if I'm listening to full tilt, probably not gonna hear the chuffing if it's gonna chuff, you know, because it's gonna be everything is gonna be rattling and that kind of stuff. So I don't really care about hitting the exactly 17 meters per second. So first I'm gonna lower the power handling down, because if I'm gonna put like 100 watts, see, it's not gonna chuff, I'm not gonna hear anything. So let's put some more reasonable value of, let's say 500 watts, yeah? Have the power, normal listening levels, it's gonna be 500 watts. And now I can make the port a bit smaller. So let's put, let's say 7 centimeters. Okay, so 17 is here, and I think it's gonna be fine. So playing half its rated power, which is like normal listening levels, I just might hear some chuffing at 30 hertz, maybe. So I'm gonna take this risk, and I'm gonna leave it as it is. So my port dimensions is 30 centimeters times 7, which is the opening, the area, and the port length is gonna be 58 centimeters. So let me just very quickly change it to inches for you guys. And square inches. Okay, so I have 11 inches times almost 3 inches. The length is going to be 23 inches. The cross area of the port, 32 square inches. And that's the port I'm going to have. Now, probably you've seen online that some people recommend, oh, you need to have a certain amount of port area per cubic foot of internal space. That is only a guideline, and the only way to see how much you actually have the port velocity and how much you're willing to sacrifice, and it's all in the design, and the only way to see it is here. You're not gonna see it anywhere else. That's why it's important to check this. Okay, now there's a few other things you can check here as well. What we can check is maximum SPL, not SPL, but maximum SPL. And maximum SPL, if you can see, this is a clear line going, and here you have like I want to say a dip, but it's just, it kind of breaks down. That means that according to this module, I'm just again gonna put all 900 watts in it, but it's not gonna change anything. According to this software, and in this box, this subwoofer is gonna start running out of steam below 25 hertz. Yeah, that means that if you're playing anything below 25 hertz, it's not gonna like it. And it's exactly the same with Cone Excursion. Below 25 Hertz, it's kind of going over the limit of Xmax, and it's not gonna like it. In SPL, you're not gonna see that because it's just SPL. It's just gonna give you a rough idea of how loud it's gonna be. So in this, it's gonna show me 119 dB, but this is without any cabin gain or anything. But with SPL, maximum SPL is gonna give me a rough idea where that subwoofer is gonna run out of steam. So it's gonna be happy playing down to 25, and below 25 not so happy. And I'm perfectly happy with it because the songs that I have, I made a playlist of songs below 30 hertz. Most of them is like 28, 27 hertz, and all the other hip-hop songs is like 30 hertz. Yeah, 30 and 35 hertz. If you think that it's like, so this design is for my kind of taste of music and what I like. If you want to design a box for, let's say, electronic music or like drum and bass and that kind of stuff, contrary to popular belief, that music is not that low. It hits in the 40 hertz range, somewhere around here. Yeah, it's not low. It's not low. Even dubstep, it has loads of bass, but it's not low. It's in like the 40s. If you're listening to a lot of rock, it's gonna be in the 50s. So again, I'm having this peak at between 30 and 40 because of my music taste, because of my listening. If I would like to make it for, let's say, drum and bass, which is in the 40, between 40 and 50, then I would shrink the box, let's say 2.5, and I'm going to increase the tuning frequency to 35. Wait, I think I can make even a smaller box. 2. Perfect. So if I'm going to listen to a lot of drum and bass, dubstep, electronic music, and I want it to be as loud as possible between 40 and 50 hertz, yeah, I need a bit of a smaller box. So 2 cubic feet, tune to 35. That's going to give me very similar to what Alpine gives. See? That's even in a smaller box. So you can see these are very similar. It peaks at the same frequency almost. It's just in different magnitude. One is a bit louder, the other one is a bit quieter, but this has a shallower roll off. And this is mainly to do with the tuning frequency, because you see for this one it's a smaller box with a lower tuning frequency, and this one is a bigger box with a higher tuning frequency. And these are the differences. So this, if I would like it for electronic music, if I would listen to metal and stuff, I probably would make it even smaller, 1.5, and I'm gonna tune it, let's say 45. See, that's even lower. Between, is gonna give me a peak between 50 and 60. So that would be very good for rock and metal. And again, you need to know your music, and not to know the genre that you're playing, but you need to know where the bass hits, where the bass notes are, because otherwise you're just guessing. So my box was what, 3.5, tuned to 30 or 32, tuned to 30. Cool. So this is what I came up with. This is going to be my project because I like the frequency response, and I'm going to try to make this box if the size is going to be, if it's going to fit in the car. I'm going to keep these vents in centimeters. Which was it? There we go, 30 times 7. I'm going to keep this port and this box volume if it's going to fit in the car. In the next video, I'm going to try to use a software that is making the actual box, because what this software does, it gives you only the internal volume. So if you take this 3.5 cubic feet, it doesn't mean that your external box dimensions is going to be, if you add everything, is going to be 3.5 cubic feet. No, this is only the internal volume. These 3.5 plus all the materials that you're going to use plus the vent. See? So it's not that simple. That's why you need another software to actually model the box itself and to make sure that it fits. So I hope it's gonna fit in my car. If not, we'll have to go back to the software and tweak it a tiny little bit. Maybe reduce the volume, maybe increase the tuning frequency, because when you increase the tuning frequency, the length of the port is gonna get shorter. That means the volume of the port is gonna be smaller. Yeah, so we're gonna try and see what's gonna happen. So this is the ported box that I'm happy with. Very quickly, we're gonna touch a bandpass. So I'm gonna choose this one, the same driver, one driver, and I'm gonna choose fourth order bandpass. Again, this doesn't matter because we're gonna change everything. So X for fourth order, create. There we go. So as you can see, it's a wide band, but not as loud. If I want to make it loud, I'm gonna go here, volume, let's put 1 and 1. So the volume of the sealed side is gonna give you the width of the bandwidth. So you see 1, if I'm gonna put 2, it's much wider. If I'm gonna put 3, it's again much wider. The other one, if I'm gonna change it to 2, is gonna give me the peak itself. Okay, so let's make it 3. It's even peakier. If I make it 4, even peakier, but it's getting narrower and narrower and narrower. If I can change the tuning frequency, or it just shifts the whole mountain, either one side, either the other side. So if I put 40, see, it's much louder, but it's much more peakier. So let's, for fun, change what am I changing? This one to see a bit more. Let's put 20. There we go, so I can see a bit more. So let's make a massive peaky box. So sealed side, let's make it very small. Ported side, let's make it very big. And let's tune it high. And as you can see, it's plus 13 dB at 50 Hertz. So but again, this is unreasonable because you need 1 cubic foot for this, 6 cubic feet plus a port is going to be a massive box. So bandpass boxes are massive, but they give you a massive peak. So let's make sound quality bandpass box. The small chamber, let's put 2 cubic foot. This one too, and let's tune it a bit lower. Let's tune it 35. Okay, and 3. No, it's gonna be too much. Put 1.5, and maybe this one 3. Perfect. So if I'm gonna make a bandpass box, fourth order, with a seal chamber of 3 cubic feet, front ported chamber 1.5 cubic foot, tuned to 35, I'm gonna have this, which is a very nice response. I'm gonna compare it to sealed. It has a roll off, as you can see, of a sealed enclosure, because again, fourth order bandpass has a sealed chamber, so it has a very nice roll off. However, it rolls off at the top end as well. So fourth order would give me a very nice response, and it would go down very deep, play all the low bass notes. So that's the fourth order. Let's make a sixth for fun very quickly, because why not? And again, this is playing with this is so much fun, and I advise for everyone to do that, just to play some hex. The more you play, the easier it gets. Okay, so for sixth order, I'm going to remove all of them. you have two ported chambers, and both of them have a tuning frequency. So let's do 2 cubic feet 2. Let's tune 1 to 20, which is not unreasonable. 30, and the other one, let's say 40. It doesn't look very nice, does it? Let's play with it. 3, no. 1. I just want to trying to have a normal shape. 1, no. 2, 3, 4. So you see, this subwoofer doesn't really like this enclosure type, because you need literally ridiculous amounts, very, very big boxes. Okay, I'm trying to make it something kinda nice. Okay, so there we go. So this is a typical 6th order response. You have 4th order, which is like one mountain, and with the 6 you have a broader, bigger bandwidth, so it plays like higher. But if you stretch it too much, if you want your 6th order to play too wide of a range, it's gonna have a dip in the middle. See, it's going down, and you have like these, it's called dog ears. And that's the beauty of it. You can play with it and have different variations. So 28, let's make it a bit nicer. 40, 50, let's put 60, 55, 2, Anyway, basically you just need to play with it and have something, whatever you need to have. But again, 6th order bandpass, it's a massive, massive box. And that's the problem with 6th order, is because you see, if I change the tuning frequency, let's say from 55 to 50, the top end changes the response by like 2 or 3 dB, and it's the same on the other side. And the thing is, to make a port extremely precise is very difficult. So like, if I'm gonna have these values, these volumes, and these tuning frequencies, and again I need to play with the bends to have the port velocities, it's very difficult to make it properly. You can just slap whatever you want and make whatever, you just make a box like this, and hope for the best. But if you're gonna have your tuning frequency, let's say if instead of 28 by accident you're gonna make it 31, see, this is gonna be much bigger than that, and it's not gonna be what you want, what you're aiming for. That's why to make a 6th order is extremely difficult, and it's extremely difficult to model. Okay, so again, let's go back to this. This is my ported enclosure that I'm gonna try to make with not exceeding cone excursion and having port velocity where I need to have. The other thing that we can check here is group delay, which I don't really care about. If you care about group delay, you can check it here as well. And impedance. So impedance, if you saw, if you know about box rise, yeah, box rise is a bad thing. This is your box rise. This shows you in a, so this blue one is a sealed, it has only one peak, and ported is gonna have 2 peaks. One is for the driver, the other one is for the port. And in the middle is going to be your tuning frequency, so in this case 30 hertz, and it's going to show you your impedance rise. Basically, you can check it here without if you know your box dimensions and everything, you can check it here to have a rough idea where it is, and it's just, you know, for fun. So yeah, this is my box, what I'm gonna make. It's been a long video, but again, you cannot make this short because there's so much stuff to go through. And that's the thing, when you're designing a box, it's not only to put it in a box and hope for the best. You need to check stuff so you wouldn't damage the driver. That is gonna play nice. It's not gonna, the port is not gonna chuff, and in general, you're gonna have a nice experience, because when you don't check any of these stuff, either you're lucky or you have a ported box that is a bit shit. Okay, so thank you very much for watching. Thank you for your patience, and I'll see you in the next one.